users of these things, if we want to secure a future for ourselves, we not only have to appeal to the customers who build them now, but also their children, their spouses, and the people who already are asking the uncomfortable questions.
I think it's essential. I mean, to be honest, if we don't do it, we become complacent. So yeah, there is pressure from clients, there's pressure from ourselves, there's pressure from our workers, there's pressure from our children. It needs to be done. You know, it's not only the fuel that we are using, it's also how the steel is being made, how the aluminum is being made, which wood do we use on the boat, how do we use less resources, and we take something from the planet and create something that's ultimately a pleasure thing to be at.
We can define rare materials that you can harvest in one way or another in a sustainable way, but the supply, by definition, is going to be extremely limited. That makes them very attractive for our customers.
We are using the planet and we go to very remote places with our yachts, and if we don't do that in a responsible manner, you probably won't be allowed to go there anymore. So it's only for that reason you have to do it.
There's a foundation that was started only 2.5 years ago. It's called the Water Revolution Foundation. I became its first chairman. And we have the major competitors of Feadship on board.
If I see what's being created currently with methanol and hydrogen, that's only possible because everybody's pointing in the same direction. And I see developments with our yachts, I see development at other yachts, and they're all helping to achieve the same goal. Listen, we built the most ultimate toy out there, and everybody has a different dream. And we have a dream in trying to be responsible, making these boats better. But if the client's dream is to create something completely opposite, we still listen to our clients, and then we make the best out of it.
Hello and welcome to the second episode of UnIQ by Feadship, Build Without Impact. My name is Kaatje van Leeuwen, your host during this virtual and interactive experience broadcast live from Amsterdam. Today we'll be exploring efficiency and energy saving to make better Feadships. We have some very interesting guests who will share knowledge from their perspective and give insight for the future of the sustainable yachts. And of course, the opportunity for you to engage in live conversation with them, so do not hesitate to send in any of your questions throughout today's episode. But let's start with some exciting news. Some of you might remember him from the first episode, Guido Loef, aka Q. A quick promotion we might state. For Guido, I am very proud to introduce to you today as my co-host. And for all of you who might remember that Guido has a big passion for building yachts with minimal impacts and of course knows everything about everything technical. So Guido, thank you so much for joining me here today, and I know you have been looking forward to this episode, so do tell us, what are we going to talk about?
Oh, that's a lot. Thank you for the wonderful introduction, Kaatje. Yes, indeed. I'm truly passionate about this subject. How do we reduce the ecological footprint of a superyacht? And by doing that, we will also preserve the natural wonders, which are actually the destination of these yachts. So I would say it is really in the heart of this industry.
Well, I can understand that that is appealing to you on so many levels. So why is this relevant for such an exclusive product that, don't mind me saying, has quite a footprint?
Yes, I understand. It may feel a bit odd, but actually that's the same thing for all luxury goods. And think of private planes, for instance. I mean, it's the same sort of products. And what I see lately is that the wealth involved with commissioning and building these superyachts is used to accelerate the technology and the solutions we need to conquer these big issues.
Yeah, I mean, that does already sound quite inspiring, and I can feel that hint of passion there. So how are we going to approach this big topic today?
Yeah, it's a huge topic. We will split it into two. First, we will start to talk about the use of the yachts. And we'll answer the wicked questions like, which fuels will they use? Which power systems like engines or fuel cells or batteries? And the second part will be about the creation process, the manufacture process. So about the materials we use, the metals for the structure, but also the exclusive finishes to the interior and the exterior. And at the same time, we need to worry about our own facilities and the things we do.
Yes, well, Guido, you have all my attention. So I say, let's dive into it. And who better can give us some valuable insights to start with than Bram Jongepier, specialist at the Voogd Naval Architects for over 30 years, experience in yacht design, engineering, and already 15 years he is very passionate about reducing and finding solutions to the impact of that superyachts have. And a fun fact is that Bram is the initiator of Yeti. It's an energy label for superyachts, like the ones you have on your fridge. I think it's marvelous. So Bram, to you.
Yes, thank you, Katje, and I'm very glad to be here. Before we start, I'd like to share a bit of Dutch honesty with our audience. The first is, this is a very complex issue. Last episode we talked about a boat, which is already a very complex machine, but today we'll be talking about this boat impacting the natural world, and the natural world is infinitely more complex. So the only thing we can do is learn as much as we can, try as much as we can to understand what happens and act on that. We all have to act, and at a certain stage we cannot not act. The second thing is zero doesn't exist. It may shock the mathematicians amongst us, but zero impact is impossible. You may walk the grass, but you cannot do that without impact. But you can do it sustainably if you give the grass the time to recover. And that is how we should treat our oceans. So what we'll be looking for today is minimal impact to make it sustainable. So how do we define impact? We look at it in two ways. First, global impact. And usually that means global warming. We're feeling it today here in the studio. So global warming is caused by CO2, but there are other issues like, for instance, the ozone depleting substances, which caused the hole in the ozone layer some time ago. The other way to look at it is local impact. So in a local environment, like you and your boat sitting in a harbor or near a very nice island, and emitting either noise or exhaust gases or maybe an oil spill. This impacts the natural world at that locality, which means the flora, the fauna, or that little bit of nature which we call humanity. So how do we look into organizing that impact? That is done via a life cycle analysis, and that is shown here on the right. So a life cycle analysis takes into account all the different phases during the life of a product, of the yacht. So for us that means materials, build, use, and disposal. And those phases we express usually in eco points. So eco points are a way to calculate all the kinds of impacts that we have. It is, for instance, that global warming by CO2, but it is also acidification, it can be land resource depletion, it can be human toxicity, which is added up all together in eco points. So how do we look at it from our perspective? In manufacture, we see mining for the steel and aluminum of our boats. We see the production of the components that go into our boats. We see transport. We see, of course, our yard's own process, the assembly when the boat arrives at our yard. For the use, at first, of course, fuel has to come on the boat. It's being bunkered. But before that is already a whole process from the well via refineries. After that, the fuel is being burned on the boat. So that means that it travels. And we know by now how that works. You've seen that in the last episode. And to give you a bit of perspective on the relative importance of the two, the use phase, which we define as about 25 years of life, is about 85% of the total impact of the yacht. So the build phase is about 15%. And what we'll do is use the Yeti. The Yeti was invented about 2 years ago and is now being developed in a joint industry project with many of our industry partners. The Yeti will allow for a very simplified and standardized approach to look at the impact of a yacht and to determine it based on an operational profile. And that concludes the introduction, Kaatje. So let's get to work.
Yes, thank you so much. And yeah, a lot of developments have been made. So thank you so much for clarifying that. But Guido, let's now look at the impact of the use of superyachts and the specific developments related to that.
Yeah, that's an exciting part of this whole program, actually. There's a lot of attention having paid to it, and I'm delighted to give you Feadships' take on this. But before we start, I want to manage expectations, because there are so many different things that we could discuss about. But we narrowed it down to the main subjects. For sure, we need to worry about the entire fleet. I mean, of course, there are future concepts, future technology, and we look at that, and we plan for tomorrow. But there are so many things we can do today. And at the end of the day, we need to get to zero, as Bram said, but we don't really know whether it can be zero and what it is about.
I mean, you're looking at me, but yeah. I have no idea, Guido. And Bram, the only thing I know is that Bram said it's not possible. So maybe Bram can clarify that a little bit more.
Yes, of course, Kaatje, I can elaborate a bit. What you see here is an analysis of the complete superyacht fleet. So not only Feadship, but all of the yachts in the world. And this is a graph that you see often, business as usual. So there are boats, we build more boats, the boats we build are getting bigger, and the boats we have built don't go away. So it will grow in a kind of an exponential way. The right part of the graph shows the impact divided over length classes of the different yachts that exist. And what you see is that despite small yachts have each a little impact, the total number of them causes that the total impact of the small yacht fleet is larger than the large yacht fleet. So does that mean that we have to sit on our hands? No. It is our belief that we, as the large yacht builders, should invent and develop methods and solutions to go into a sustainable direction and let them trickle down the market. Because we do that together with our suppliers, and they will sell to our competitors. To put this in a bit of a future perspective on how that will have to be done, at the top, of course, the business as usual graph. And the first thing, of course, that you have to do is save energy and make more efficient systems. But there is a bit of a limit to that, and it is a gradual process that takes time to develop all these technical solutions. So we estimate this will not be the total solution. We can get 40, maybe 50%, but not much more than that. So the rest of that will have to be done by the fuel. And these alternative fuels are coming to the market now. So they have been developed over the last decade, and they are now a viable solution. And this will cause our route to almost zero. Now we know that yachts operate at a quite standard way. So 90% of the time they're usually sitting still, either in harbor or at anchor, and 10% of the time they're actually sailing. So even that sailing takes place at a certain kind of distribution. They don't sail all at maximum speed all the time, of course. And as a little example, Ecstasy there was designed to do 35 knots, and she does, but usually she travels about 15 knots. So with that information and information about the yacht itself, we can put that in our Yeti tooling, which is running as we speak. It's being tested in the group, and get information on how to distribute the impact of our yachts. For instance, we know which source our energy is coming from. So how much will we get from shore power? How much does the generator provide? How much does the propulsion engine? Or in a diesel-electric boat, the total generator sets. Also, the division of impact seen on the right, you can split it up in the various substances and emissions that cause the impacts. So on the right, you can see that actual CO2 and the production of the fuel are the very major items that cause impact, because Tier 3 has caused the NOx to be reduced, and of course we fit diesel particulate filters to clean up the exhaust, so that is gone also. So we have to look for a fuel option. And there we see two challenges. There is the net zero carbon operation, which means that we stop the CO2 emission, which causes global warming. The second thing is a zero emission mode for pristine environments, like in the Norwegian fjords or in those very pretty islands in the South Pacific. Zero local impact is not always the same as zero carbon operation. So with that, I'd like to return to the panel and see what they think.
Yeah, thank you so much, Bram. Yeah, it's getting very clear. It also does raise a lot of new questions.
Yeah.
So considering the fleet's contribution to global warming, Guido, what are some solutions, potential solutions?
Yes. Well, for sure we need to think of the fact that these fuels that may be the solution won't be there at once and everywhere. So the question is, and not only for superyachts, but actually for the entire shipping fleet, is we need fuel flexibility. We need to build the yachts today that can make the transition, perhaps with a couple of modifications, but not a lot. And it may be difficult, but I'm sure it will work, and therefore, we will do it.
And what do you think is like the contribution of the community of the superyacht industry?
Yes. Well, I think we will referring to this a couple of times, but superyachting is actually a special place, especially comparing it to the rest of the shipping fleet, which is dominated by low freight rates. Superyachts may be able to afford the premium on these fuels, and by doing that, bring down the cost, and so for others to afford it.
Yeah.
And I think if we explain this to the clients, I'm sure they want to make a difference. At least they will accelerate it.
Yeah, no, I think that's a great idea. So I think we should discuss this with our guest today, Guido, because we have some wonderful guests here. Ilko Dekker from the Methanol Institute and Joost Schapendonk from Pond Power. And later on, digitally, we will also have Johan Berggren of PowerCell in our midst. But Joost, first a question to you, because you are an expert on engines. So how can you tell us if you can make engines fuel flexible?
Thank you, Kaatje. Yes, we can. But when talking about fuel flexibility, we often talk about these exotic new fuels that are coming. But on the screen of Bram, there was already another component that I would like to discuss. That's HVO. HVO is a second-generation biofuel. and it's produced using hydrogen. It's taking impurities from the feedstocks. It's taking oxygen from the feedstocks, and this results in a fuel that is lacking the drawbacks of the first generation fuel, biofuels, FAME. Like for instance, the shorter storage times due to oxidation, or the growth of bacterial, the bacterial growth that you get when it's in contact with freestanding water. And this makes the second generation fuel something that we can use today because it's available today, but it's a drop-in replacement. So.
Well, that's very good news, because as Bram explained, there's already a current fleet, and perhaps this will work for the current fleet. But I know that this HVO has different specifications compared to the diesel that they use today. How does that work, and can you run on them, also on engines which are older?
Yes, you can, Guido. Yes, it's true, it's a different specification. It's a different fuel. So, for instance, it complies to a different norm. It complies to EN 15940 instead of the EN 590 that the crews use to today. Because of the large variety of feedstocks, Caterpillar has looked into this and came to the conclusion that it's impossible to test them all. But looking at the specifications, they also came to the conclusion that it's, as I said earlier, a drop-in replacement. So without any modification, our engines can run to it. And in retrospect, they also came to the conclusion that this is the case for engines built since around 1990. And another benefit is that if your engine is maybe not 100% ready for this, you can also run it in different blends. So EN 590 together with this HVO in the ratio that fits your engine. But I would recommend customers considering this to or contact Feadship or contact us, and then we can help them out in making this move.
Yeah, well, interesting. And I'm sure this won't be the end solution. So what sort of other solutions have you considered and are you currently working on?
Well, now it becomes interesting. Yes, we've been looking into the larger alternatives as well. We've been doing that for a couple of years. And we've been comparing the alternatives to each other because they all have their pros and cons. For instance, the technologies for natural gas are widely available already. There's engines running on them. But for instance, the storage of large quantities of LNG on board of a mega yacht would be problematic, or could be a challenge. That challenge even becomes bigger when looking at hydrogen. You need a lot more room for that. Then ammonia is also mentioned as an alternative. But ammonia has very low flame speeds. Mm-hmm. It's a bit more technical, but therefore it's deemed not suitable for high-speed engines that are often used in superyachts. Mm-hmm. And then we're not even talking about the toxicity of ammonia. So, making all these comparisons, we came to the conclusion that methanol, biomethanol, would be a great candidate as a transitional fuel for a large part of the marine industry, among which the superyachts.
Yeah. And can you then just convert an engine to run on methanol, or can you use the existing engines?
Well, there's a bit more involved there. To better understand this, we've been working together in a joint industry project. Yeah. Feadship has been part of that as well. Green maritime methanol. As part of this program, we even converted an engine ourselves from a gas engine to a 100% methanol engine to really learn and understand what's involved in doing this. But let's be honest, we're a dealer, we're not an engine manufacturer. So the methanol engine for the future needs to come from our OEM, Caterpillar. And they will design and build, develop and certify, also very important, this engine to bring to the market. And as it looks now, that will be in around 3 years. That's the timeline. Oh. And that 3 years is needed because there's about 5 or 6 technologies that you can use to convert an engine to a methanol engine. And they all have their pros and cons, their advantages and disadvantages. And a large part of choosing the right technology is basically which sacrifices do we want to make in, for instance, performance, range, power density, And to make the right choice there to fit the needs of your customers.
Yeah. Well, that's very interesting. So HVO short term and
Yes.
methanol mid-term, and after that, we'll see, right?
Who knows?
That's a very comprehensive overview already, right at the start.
Wow.
Kaatje.
Yeah, it's quite a lot, I have to say. So just for my understanding, what I got from it is that we can still run on diesel, but a renewable version of it, and that methanol is also a very great potential solution, right?
Yes.
Great, but Ilko, could you explain to me what is the difference?
Thank you, Kaatje. You know, I've been working in the alternative fuels industry for close to 15 years now, and I still learn new things every day. So I can imagine for you to take this in all in one go, there's a lot to digest.
It is.
So let me try and explain a few things. In those 15 years, I've seen a lot of developments in the biofuel space. Used biofuels on the road, in aviation, and in shipping. And the example that Joost gave with HVO, one of the largest production facilities of HVO is actually here in the Netherlands, in Rotterdam. And let's not forget about methanol and biomethanol, because a large amount of biomethanol is produced right here in the Netherlands. Methanol typically is known as a chemical commodity. It's used to produce products that we use in our daily lives. And actually the use of methanol as a fuel has really taken off in the last 5 to 10 years, and it's growing very rapidly. And there's a couple of very good reasons for that. And it's a little bit technical, but you have to imagine methanol has the highest hydrogen to carbon ratio of all liquid fuels. And that small statement actually has two very important elements in it. Methanol is liquid at atmospheric pressure and ambient temperatures, and it contains a lot of hydrogen. Actually, it contains more hydrogen per liter than a liter of pure hydrogen does. So it actually is a very good hydrogen carrier for fuel cells. But I know Johan will be talking about fuel cells. I don't want to steal his thunder. A very important element of methanol is that it has no carbon-to-carbon bonds, which means it burns with a very clear flame. And for those of you that like motorsports, I'm sure you have vivid images of some incidents in the IndyCar series where you could see that the fact that it burns with a clear flame. But if I translate that to your industry, what does it mean that it burns with a clear flame? It means that it produces basically no soot, no particulate matter. It produces no SOx, hardly NOx. So it's a very clean fuel that has an immediate impact on reducing your local impact. And since we're talking about environmental credentials, methanol can be made from a very broad range of sustainable feedstocks. So that helps you get to net zero carbon. And it is biodegradable. So even though you want to try and avoid having spills, accidents do happen. But when you have a spill of methanol, it is very benign to the marine environment. So you basically wouldn't notice it.
Oh, that sounds like a very good, say, properties of a fuel. It seems like it's very close to addressing both issues, net zero carbon and zero local impact. But how about the availability in the world?
Well, actually here on Earth, it is a natural occurring compound, but not just here. Scientists have found large quantities of methanol clouds in outer space. So imagine Feadship decides to start building space yachts. There's one thing that you know for sure, there is plenty of methanol out there to continue going from one planet to the other.
Yeah, sure we will try that one day, but we have to solve a few other issues as well, I think.
Yeah, well, if you do, I'll sign up. But all joking aside, if I go back to our situation right here on Earth, methanol today is primarily produced from natural gas. So you can imagine if I take natural gas and displace it with biogas, I can produce biomethanol in existing facilities. But we can produce it from household waste. There's a project announced here in Amsterdam that will do so. You can produce it, for example, from residues from the forestry industry, from the pulp and paper industry. And the one that I personally am the most excited about is you can produce methanol from renewable electricity and CO2, so-called e-fuels or power-to-X. And there's a lot of different types of fuels out there that can be made in the same type of process. But methanol is one of the most energy efficient ways of converting electricity to a liquid. So methanol is scalable, it's available, it's affordable, and it's sustainable. And it's for that reason that we already have some 15 commercial vessels operating on methanol around the world. Maersk, the large Danish shipping conglomerate, has announced that they will launch their first container feeder vessel in 2023 to operate on methanol and from that year onward. So actually, methanol is already in the lead in commercial shipping, which then begs the question to you, Guido, when will the superyachts start operating on methanol? And how do you see the use of methanol on superyachts?
Yeah, that's a really good one. Yeah, so there we may be even following the commercial shipping. Because, yeah, I think it could work, and Bram will show us a bit later on how it fits in a superyacht. But drawing back a bit is that you were talking about producing materials from methanol. And that brings to my mind, well, why is that? No, so what do you produce, and how relevant is that for our product? And also, what is that doing on the scalability?
Absolutely. It only helps to be able to provide a solution both on the fuel side as well as on the material side. I mean, methanol is a chemical commodity that is used to produce paints, plastics, resins, adhesives. So all the kinds of materials that you need to build your beautiful superyachts. And just to name a couple of examples, in the port of Antwerp, there's a power-to-methanol project that has recently been joined by INEOS. Staying in Belgium, there's a project in Ghent where the CO2 from the ArcelorMittal steel mill will be used to produce renewable methanol. In Bavaria, in Germany, Wacker Chemicals, who produce silicones, intend to use CO2 on location to produce renewable methanol to make more silicones. And there's projects everywhere in the world. There's projects in Sweden, in Australia, in Chile, in Morocco, in Spain. So you can see that really everywhere around the world this is going to be produced. And that's why I'm confident that methanol has a good chance of being a future-proof fuel.
Yeah, so it's actually happening. That's a lot to swallow again.
Yeah, but I think you explain it very well. And I think if Bram can give me some visuals, I might actually understand this.
Sure.
I'll try to do so, Katja. So this is the regular way to show our process. This is what we always have done. This is well to wake. At the well, fuel is extracted, it is being refined, it's being made into a marine fuel, it's being distributed to the yacht, and there it enters the tank. And tank to wake, the fuel is used on board. This is, of course, old school. We should go well to wake, we should go sun to fun. And this is close to what Eelco described. So we have a lot of sustainable power being developed in the left-hand side of the figure, which enters the grid, and we can either directly use it on board when it's on shore power, or we can modify it into hydrogen with an electrolyzer, put the hydrogen on board, or we can go further and make an e-fuel of it. So that can be either an e-methanol or maybe even e-diesel. But we should always be aware that all those conversions that we do to arrive at a certain product cost energy, and energy is loss of efficiency. So back to you, Katja.
Thank you so much, Bram. And yes, I'm very happy that you are making these complexities a bit more tangible, so thank you. And let's now cut to another guest, Johan. I believe that PowerCell has already a long history in the development of fuel cells, but also reforming technologies. Can you tell us something more about this?
Yes, thank you. It's fantastic to hear about all these future fuels coming around the corner. We have about 30 years of experience of reforming fuels, hydrocarbons into pure hydrogen, but we are also now focusing more on pure hydrogen fuel cells. So being the process of reforming, you're actually extracting the hydrogen from the hydrogen carrier. In our case, we see it as a carrier of hydrogen. very, very nicely described here by the experts in the panel. And the maturity of the fuel cell as an electrochemical device is actually quite mature, and it's widely adopted in the business. We have seen thousands of forklifts running on pure hydrogen, and we're now seeing the automotive industry moving into pure hydrogen solutions. So this is happening now. And of course, for the future, where you see the long distance shipping alternatives or the long distance sailing alternatives, that's where probably we will see other types of fuel cells coming into play as well. So like the solid oxide fuel cells, the high temperature PEM fuel cells, those kind of fuel cells developing into in this future context.
Well, thank you, Johan. Referring to the low temperature PEM cells that you were talking about, being mature technology, how do you see the implementation of those systems in our superyachts? So where are the advantages of doing that?
The advantages are simply that they are available, they are scalable. From smaller power units you can make larger power units. So in that context it's viable. They are also quite durable. They are efficient as well. So using pure hydrogen in a fuel cell without any sort of conversion steps, that is very efficient. So the least sort of space needed for reforming technologies as such. Of course, there are hurdles that has to be overcome, but those we will solve together with your naval architects when it comes to the integration of the fuel cell itself. When it comes to the storage, I think we can discuss that there are some topics there as well, and some challenges with that part.
Yeah, so talking about these challenges you were now referring to, connected to the storage, can you add something, elaborate a bit on that?
Yeah, of course. The storage of pure hydrogen, if you look at the alternatives you have, is basically compressed hydrogen, or you can go for a liquid hydrogen. Liquid hydrogen is cooled hydrogen, so you keep it in a thermal container. The size of those storages depend, of course, on the shape of the actual container. And it's really not optimized to have a cylindrical volume in a square-shaped environment. So the space that you have to claim is a bit not really favorable. But of course there is possibilities to do it, and let's see what the future holds for these kind of storages when they develop and get more efficient by space.
Well, thank you, Johan. Yeah, indeed, those storages are things to really worry about and look at solutions. And Bram will actually show something about that in a moment. But before continuing, Katja, I think it will be really joyful to have a look at some new engineers that actually are already working on this technology.
I think that's a great idea and a perfect timing.
Good.
Hi, my name is Simone Vis.
And my name is Gerber Rijpkema.
And we are from TU Delft's Soloboat team. This year we are a group of 20 ambitious students that work on a project Hydromotion. In this project we design, build and race a hydrogen-powered boat within 1 year. With this boat we will compete in the Monaco Open Sea class, a race that's organized by the Monaco Yacht Club. It's our mission to inspire the maritime industry and to accelerate the energy transition and shape the engineers of a sustainable future.
We believe that superyachts and racing boats have a thing in common. They can both be seen as the front runners of the maritime industry, where anything is possible. Boundaries can be pushed and innovations from laboratories can be used in actual use cases. Together with Feadship, we set up a design for our hydrogen system. We use hydrogen as a pressurized gas to be used in a fuel cell. This fuel cell is supplemented with a battery pack for peak shaving. Combined, they drive a 70 horsepower electric motor.
Hi, I'm Taco Lambrechts and I'm a graduate intern at Feadship. At Feadship, we try to implement technologies of this fuel cell lab and of the Hydromotion team into our superyachts. This way, we provide our clients with a clean and sustainable yachting experience. One of the major challenges of fuel cell systems in superyachts is the use of alternative fuels. That's why I'm designing a system that is fuel flexible, so multiple alternative fuels can be used to generate clean power.
Wow, wonderful. Now, I love that Feadship is so involved with the next generation, and I wonder, like, what does Feadship learn from these students?
Well, various things. And to start with, it is a lot of fun to work with them. And it's amazing what Delft University has done with all the dream teams. I mean, they race solar cars through Australia, join the Hyperloop Challenge, and now have a hydrogen-propelled hydrofoil racing boats in front of the Monaco Yacht Club. So that's really interesting. And, you know, we rely on these people, on these the new generation, for our future. What we learn from it, for instance, what Taco just was referring to, fuel cell technology is very relevant to us, but we need also to look at the fuel flexibility there. So how do we get that one flexible? So I have a question for Johan. I know that you have been working on reforming technology. You were already referring to the solid oxide fuel cell technology. So what sort of benefits do you see there?
Obviously, solid oxide fuel cells, they are running on higher temperature. So actually you could utilize this temperature in the reforming process of the total fuel cell plant. That is a benefit of those kind of systems. On the other hand, they are a little bit slow in power dynamics, so you might have to combine them with the batteries or even other types of fuel cells like the low temperature PEM fuel cells that are more dynamic and can take the instant loads. So that is it's a combination of many different systems in the future, and we will see what is actually the winner in the long run.
Okay, thank you, Johan, for that. Well, I think, Kaatje, it's time to give it over to Bram, because I know he is working on this very often, really fighting those systems and fuels into the designs.
Yes.
But, you know, it's always the same.
It's always the same, Guido. The big question, does it fit? Bram.
Does it? Yes, well, we made a little exercise for ourselves to see how the various fuels would fit or not. We start out with about 100 meters of yacht, and we slice out the middle third, so about 30 meters, and we say we'll have to put our energy in there. This is today's technology. So normally we'll put in diesel. That fits in the double bottom of the yacht. And we can, of course, exchange that to HVO, so renewable diesel. When we go to an alternative fuel, we look at methanol. Methanol is slightly less energy dense and needs some additional safety features around it. So in the end, it will take 2 to 2.5 times more space than regular diesel. But these two fuels do not allow for a full zero emission mode. So for that, we want to go to either hydrogen or batteries. So let's check those. Hydrogen, liquid hydrogen in itself has an energy density which is about a quart of diesel. So that means it takes 4 times as much space. On top of that, like Johan already explained, it's contained in cylindrical tanks, which you cannot hide in the double bottom. There are additional safety zones around it, and it has to be inward of a certain size from the beam of the boat. So you end up with this. So this would take already quite a considerable redesign of the yacht, because you will lose a lot of interior. And even to get the same interior back again, the total interior volume of the yacht has to grow by about 100%. Moving then to batteries. Batteries, of course, have an even lower energy density and also a very high specific weight per energy. So that would end up like this. Well, you can imagine this boat would either sink, capsize, or both. So a full redesign is necessary. Stressing, this is today's technology. And also, yes, if you really want it, we could do it, but it would be a totally different yacht than what we are used to. And we expect that in 10, 15 years of time, we will have those 40–50% of savings, we will have different hydrogen carriers, and we will have better batteries. So by that time, it may actually be possible to combine local zero impact and net zero carbon operation. For now, we must look in a different direction. We know that the operation of our boats isn't always max speed, but it also isn't always max range. So when analyzing the trips that our boats make, we see that the normal distance of a trip is only 30 miles. And of course, when an owner is on board, these trips are short, and the longer trips are made with the crew. So we know this. And how can we use that? When we define a margin or a border at 2.5% of range, you can actually see that a majority of the trips is less than 2.5% of that range. So 125 miles, if you compare it with 5,000 mile normal range. Enter the energy hybrid. So the energy hybrid means that you have two kinds of energy on board. And that would mean, for instance, methanol for your long-range, zero-carbon, net-carbon operation, and a big battery, or hydrogen for your local range. And because of this trip distribution, you will actually see that most of your trips are done with that zero-emission mode. So 70% of all trips can be done without emitting anything, and that would mean about 30% of the sailed distance with only 2.5% of range. And all of this is enabled by electric propulsion, because electric propulsion is very, very suitable to take power from different sources. So, does that fit? 2.5% of the total range with today's technology. So here you can see in a 100-ish meter yacht, two fully engineered solutions. So yes, it will fit. And for today, this is a very, very nice solution. And with that, I'd like to give it back to Kaatje.
Yes, thank you so much, Bram. It makes a lot of sense now, or a lot more sense to me at least. So thank you, Bram. Joost, so we've been talking about fuel cells. How do you look at this, and how far do you think we can stretch the life of the engine?
Well, Kaatje, when talking about decarbonization, it's actually not about the engine, it's about the fuel you burn. So part of our strategy is to basically keep the engine and all the nice benefits that it has, and then change the fuel. So we get away from emitting pollutants and connect to this decarbonization strategy. But we do see other alternatives to the combustion engine coming into the marine space. And even we, as an engine manufacturer, we don't plan to be a dinosaur. We're also looking into these kind of technologies and then how to smartly combine them together with the internal combustion engine into smart, tailored solutions tailored to the application. And these hybrid solutions, they will bring higher efficiencies, but in the same time, they bring some very nice operational benefits. So I think that's the future you're asking about.
Yeah.
It's good that you're talking about the future, but actually there have been already quite some recent developments the last, say, years. Which ones are most significant for you, and what are you expecting more?
Guido, there's quite a lot that has already been done. These are often smaller steps, and they're steps that are happening right now. For instance, the emission legislation has driven us to add after treatment to the engines. Basically, it's not possible anymore to comply to legislation without after treatment. Mm-hmm. On land installation, it was already been done for 15, 20 years, but now basically every new vessel needs one. The interesting option that came to light with that is that, say 20 years ago, engines were fuel optimized, and with engines becoming cleaner over the last 2 decades, basically the fuel consumption has gone up. Now with the after treatment, that we clean the exhaust after the engine, mm-hmm. we can basically go back to fuel optimized engines. That's only a couple of %, but you see that new technologies open new doors. Another option that's coming into the market, especially with the diesel electric or methanol electric maybe in the future, vessels, is variable speed gensets. This allows us to run the engine on the ideal RPM for a specific load. And that has some significant savings. That can go up to 10, 15, or even higher percentages of efficiency. And there, of course, it is the fuel that you don't burn that doesn't create emissions as well. And then last, when you add fuel cells and batteries to the installation, that gives the opportunity to run smaller engines on more optimized load points. So these are all the small steps that can be taken today already. And that's...
Well, that's very interesting, especially the last one, a hybrid system, so to say. And a couple of years ago, 6 years ago, we created one.
Yes,
one of the first one.
Yes, we did. So first of all, thank you for bringing it back to where we already stand in our developments. And that does bring us to a special guest I would like to introduce to you. She is a special lady. She is 83 meters in length, and most people respect her as a leading lady. And I think we could be great friends. Her name, Savannah. So here I introduce you together with her chief officer, Daniel Smith. Welcome, Daniel.
Thank you for having me, Katja. It is always a pleasure collaborating with Feadship. 6 years on, and I still get excited talking about Savannah. It's because the people that this vessel and program attract are those genuinely interested in advancing the status quo. Feeling like you're part of the solution really does remove the acidic effects that conflictive human behaviour can have, enhancing our clients' most valuable commodity, their quality of time. Here on board Savannah, we integrate the use of multiple hybrid propulsion modes depending on our setting. With an ultra-efficient, medium-speed direct diesel engine, we can couple our propulsion shaft to an alternator to provide the charge for our 1 megawatt-hour battery bank, thus harnessing latent energy. This is most commonly utilised on overnight passages that, when paired with our streamlined hull shape, easily provides for a full state of charge upon morning. Our DC batteries are far better equipped to deal with the constant fluctuations in hotel power load that we experience with guests on board. By absorbing these spikes in demand, the lithium-ion cells are able to provide more consistent running conditions for our generators. The upside this has on engine maintenance requirements translates directly into more time on the water for our clients, alongside a reduction in emission of particle matter and nitrogen oxides. Increased battery bank capacities, like we're seeing in new Feadships, provide an even greater prospect for cleaner operating efficiency. They also improve the scope of application for running on purely electrical reserves alone. At present, we are able to propel ourselves electrically at 8 knots whilst accommodating normal auxiliary system loads for approximately 1 hour. Coupled with technology like dynamic positioning, it has also allowed us to access more pristine marine reserves where vessels under combustion motor are simply not permitted. Adding to the positive impact that a holistic design already has on diesel consumption, it will be these advancements that enable the shift to alternative net zero carbon fuel that will begin to burn at a lower octane, so to speak. Hydrofoiling is another technology that aims to minimise resistance, and with it we will see the mainstream adoption of electrically propelled foiling tenders in as little as 18 months. These will charge on board along with jet skis and bikes, much like a Tesla is already doing in your own home. Personally, I am most excited by the freedom in design that future alternatively fueled hybrids allow by means of splitting and decentralising the conventional engine room. Having 6 medium capacity generators and/or turbines indirectly powering a propulsion setup consisting of 2 to 4 pod/thrusters not only delivers prime real estate back to the hands of the design team, but in my case, provides a sense of redundancy that gives the confidence to push the boundaries of the world's most formidable terrains. This, alongside the advancement of sustainable fuels, will be necessary for a luxury industry like yachting to survive the rules that are sure to be imposed under the UN's tightening carbon footprint regulations. My hope is that I shall one day leave this industry knowing that I edged the forefront of yachting closer towards complementing the very ecosystems that make up this beautiful world around us. I ask this important question to you now, Feadship. How is it that you plan on being remembered?
Thank you, Daniel. It's so wonderful to have these insights in this beautiful hybrid Feadship. I love it. So, Guido, how about reducing the energy that we need to move the yacht and also to use the facilities on board?
Yeah. Well, Kaatje, that question is on the money, so to say. Yeah, of course we need to reduce the energy the yachts consume, because not only it will allow that we can contain the new fuels on board because it takes more space, at the same time you would need less fuel, so less money involved because these fuels will become more expensive. So that is very important to do, to reduce the energy.
Yeah, but I think that Bram, of course, Bram, will probably have some great ideas to down this energy consumption. So,
always, Kaatje, always. Don't get me started. Yeah, the list is endless. What I'd like to do is focus a little bit on an aspect that we haven't touched upon yet today, which is heat. And heat on board is actually used in a lot of systems, for instance, for heating your pool, for heating fresh water, for preheating the engines. So if you see the division of energy on board, you see that about 15% is heat. So this is a large quantity. On the other side, our diesel engines have a certain efficiency. So from the 100% of energy that we put in it, about 35 to 40% is actually used in mechanical energy for either propulsion or an electrical generator. So about 60 to 65% we throw overboard via the cooling water or the exhaust. So of course we have to make use of that heat. And we do currently to just use it directly to heat that pool or that freshwater system or the AC return air. But there is a lot more that we can actually do with it. You can create cold with it. So air conditioning systems are close to the market that actually use waste heat to create cold. You can even make electricity from it if the heat is high enough. And the same goes, of course, for fuel cells. If you have heat, you can do stuff with it. Apart from that, and in the future, there are a lot of things that we can do, and I won't go into all of them. But for instance, we are installing large batteries on board, which means that our generators won't be running all the time. So we go to heat buffers. We stop the boat from pitching and harvest that energy. We use robotic hull cleaners to prevent fouling resistance. And the list goes on.
thank you so much, Bram. Well, I think we could continue this conversation for a long time, but I think it is time to invite the audience into the conversation. And I can see that already we have a lot of very interesting questions. And Bram, believe it or not, the first one is for you.
Yay.
So there we go. Do Flex State already accept biofuels on board?
Regulation on fuels is still under development, and yes, in special cases they do. For instance, like Joost already said, if the engine manufacturer has a type-approved engine which allows for a second generation biofuel, then class or flag will say fine. If you go a bit more exotic, like hydrogen, you'll have to show that safety is being created. And you'll have to do risk assessments for that specific design, that specific fuel.
Thank you so much, Bram. That question was from Mark, by the way. Another question for Joost. Are AVO without carbon emissions or just net zero? A question from Malcolm.
Oh, it's a net zero fuel. So there is carbon in there, but it's basically circular. So that's why we see it as a net zero carbon fuel.
Thank you so much for clarifying that. A question to you, Guido. LNG is getting a lot of press in shipping. Does the panel see LNG as a realistic option for yachts?
Well, certainly it's something that we could consider. But it's a bit similar to the graphs that Bram showed on the cryogenic storage of liquid hydrogen. You need to also have cryogenic storage for the natural gas, because you also need to liquefy it. It takes quite a bit of, say, space. It is an interesting solution because it is fuel flexible, because you could also produce biomethane, which is very close. So it can be interesting, but there's quite some space penalty there. So,
Difficult.
Difficult.
Difficult. A question from Nick to Bram. Does Feadship really turn away new build orders if the owner wants diesel engine propulsion?
Tough question. Thank you, Nick. No, we are a custom yacht builder. However, we will do our utmost to say, okay, yes, you want diesel engines, you want to be ease of mind, keep it simple, but we will say, let's make sure that you will be able to use that sustainable diesel that will be on the market next year and will be pretty well available in the years after. However, consider the consequences. This will be a more expensive fuel. Make your choice.
Thank you, Bram. Yeah, you are very popular because I have another one from you, from Bernard. Is Feadship currently working on a sustainable yacht using alternative fuels?
Well, of course, we don't say anything about our yachts, which are in build. We leave that to the owners. But we can build everything. And like we showed you, we have engineered solutions for hydrogen, for batteries. We know which engines can run on HVO. We have joined the Green Maritime Methanol program, so we know and we can develop whatever solution the owner wants. Bernard.
Well, thank you, Bram. I think we do one more question, seeing the time. It's for Johan. Are you still with us, Johan?
Of course I am.
Thank you so much. Okay, there we go, Johan. This is another question from Malcolm. Don't you need high temp PEM, to take advantage of using the heat for reforming and waste heat energy recovery?
Yes, that's clearly a potential to use high temperature PEM systems. Even better maybe to use SOFC systems which run on even higher temperatures that we can recover this energy. But actually the technology that we are using, the low temperature PEM, in combination with reforming that could come from other heat sources on board that we could utilize, is actually also an option. So I would say you have the solutions available today, as Bram explained here, and that's clearly the message here.
Thank you so much, Johan. Thank you. Unfortunately, we have no more time for questions right now, but do ask your questions because we will do another round at the end of this episode. And if your question have not been answered, we will see to it that they will get answered by some of our team through social media. So do stay tuned. Guido,
Yes.
I think maybe a little recap before we move into the next big topic of today.
Yeah. A recap of so much information. Well, thank you for that for that challenge. Well, what I take away from this is that a lot of things are, well, there. We can start using it. I mean, extreme concepts can be built actually, and there are very viable solutions. So we should just do that, and we should keep on investigating what the actual impacts are and look for those breakthrough innovations, because they will help us to make the next step.
Yes. Well, I totally agree with that, Guido. So thank you for narrowing that down so nicely. So maybe before we move on to the next topic, let's introduce the next generation.
My name is Jeroen Bruin and I'm an assistant professor at Delft University, where I specialize in maritime operations and management. My current research primarily focuses on the sustainability and the energy transition currently affecting shipping. For the sustainability perspective, it's good to look at the ship production, where we have a choice of materials that we could consider. But of course, looking at production alone is not enough. It takes 30 years for a ship to be replaced. So we're also looking at refit. And refit is one of the things that my student Nout van der Vliet has been working on for yachts.
Hi, I'm Nout and I'm a graduation master student at Feadship. As we know, only the building of new sustainable ships is not sufficient, but the current fleet must be adjusted as well. To gain insight into this green refit, I'm creating a selection tool that compares the cost effectiveness of green refit options with the impact reduction in both global warming potential and cost to society.
So beside the production, of course, the operational life of a yacht has a very large impact on the sustainability. To reduce this, we are working together with the yachting industry on the YETI, the Yacht Environmental Transparent Index, which is basically an energy efficiency indication just like you have on your fridge, where you can see how energy sustainable a certain yacht is compared to other yachts. And in the operation, you can think of solar panels, on LED lighting and on peak shaving, all measures that can help improve the sustainability on the yacht. Especially on the peak shaving, Fons van der Elsen, one of the master students here, has been doing his thesis work.
I'm Fons, and I'm a graduate student intern at Feadship. My research focuses around alternative energy storage systems, which can be used for peak shaving. Peak shaving is the process of leveling out power fluctuations in order to improve generator efficiency. One of the alternative energy storage systems is a supercapacitor, which can be used for leveling out power fluctuations for which batteries might not be suited.
The operational measurements that we are currently considering are not enough to reach the goals of the IMO in 2050. So we also need to consider a change of fuel. And currently, the total list of fuels possible is about 52, which means there's a lot of choice and a lot of uncertainty. Of course, the main known fuels are ammonia and hydrogen and methanol, where hydrogen is currently tested by the Hydroboat team of the TU Delft, and methanol is currently researched by Maarten Kries, another master student of us.
My name is Maarten and I perform my graduation research at Feadship. I research the impact of methanol on yachts. Methanol is an alternative fuel that is liquid at room temperature, which means that it can be stored in normal diesel tanks with only a few adjustments. This is important to minimize the impact on the complex design of the yacht. Therefore, methanol can be a net zero CO2 emission solution that has a relatively small impact on the design.
Guido, the next topic of today, the manufacture of the superyacht. Do tell us more.
Well, I will. Manufacturing a superyacht. Actually, it starts with mining activities, where we extract the iron ore, we start producing steel, we use that to build the structure. But as well, we will have other materials like plastics and paints and fairing compounds. And we use quite a bit of exclusive, more rare materials in the finish of the interior and exterior. And then, of course, we have our own process, our yards, our offices. Everything is part of that process.
Yeah, so there's a lot of things to consider, and Feadship only covers a part of that entire chain. So do you think that Feadship could have influence on that entire supply chain or not?
Yes, for sure. Of course, our own process. I mean, there you have full influence, and we have to do what we can, and we will discuss that also now. But our supply chain is, our direct supplier, we have influence on them because we can ask, besides their specification, their cost, they're also ask for that declaration of the footprint of their product. And that's something we have to start doing. And by collaborating with them, we make the difference.
Yes, indeed. Well, I am very excited to discuss this further with our new guest today. So let me introduce to you Amanda McIntosh of Bayards Aluminium Constructions, Charlotte van der Kerk of the Klerk Binnenbouw, an in-house interior supplier of Feadship, and Lisette Kozijnse of Feadship Refit and Services. Ladies, thank you so much for joining us today and discussing this very important topic. And I believe, Guido, you have a pressing question.
Yeah, sure. Yeah. My first question is for Amanda. Bayards is producing alloy structures, especially superstructures, for our yachts. How do you look at the subject of sustainability, and what do you do about it?
Well, let's first start by saying that sustainability and carbon footprint reduction are not new topics for us. At Bayards, we are a company that is organized around sustainable production material, aluminum. And aluminum can be recycled over and over again. But we also believe that we really have to look to our manufacturing process and to the entire supply chain. And by looking at that, by being critical, we really need the support of our clients, of our suppliers. So we partner up throughout the entire supply chain, and we set a new standard of transparency and trackability. And with that comes corporate responsibility, which creates a ripple effect, and then all other industries will benefit.
Yeah, I think that's the way to do it. And but we are starting with aluminum, not just by chance, because actually aluminum has a very big impact on global warming. Why is that? And where in the whole manufacturing process does that happen?
Well, you have the refineries, but then comes the smelting process. And the smelting process really requires a lot of energy. And luckily today, it is possible for smelters to use green energy, like hydro or geothermal power. And of course, for us, as a construction company, we really like to source this green aluminum. However, it's not that easy because it requires that we need to cooperate with the entire supply chain. So the refineries, the smelters, but then also the casters, the extruders, and then comes the construction company. So that's quite a challenge still.
Yeah, there's a lot to manage, I guess.
It's a lot to manage, a lot to control.
Yeah, and the smelting process is very close by to the actual raw material creation. And so then I think of, well, couldn't we use beer cans, recycle those, and produce a superyacht superstructure?
That would be brilliant, right? But unfortunately, we cannot. Oh. It is true that aluminum, the biggest advantage of aluminum is its perfect recyclability. But for yachts, we need a very high grade of alloy. And today, it is not possible for every alloy to be made of recycled aluminum. Mm-hmm. We really need to invest in this technology. We really need to improve this technology. We need to work together with research centers so that in the years to come, we can increase the percentage of used recycled aluminum to even a higher percentage.
Yeah. Well, thank you so much for being so transparent on where you stand with the company. So thank you so much. And maybe Bram can give us some visuals
of course,
clarify this more.
Yeah, this is basically what Amanda just explained. So aluminum has a decent impact per kilogram produced. So 17 kilograms CO2 per kilogram of aluminum is emitted in the worldwide average production. And you can see on the lower side of the picture that 13 of that 17 kilograms are from the smelting process. And this is why the smelters which operate in Iceland or Norway or New Zealand, where there is an abundance of renewable energy, can actually provide you with aluminum which only has a 4 kilogram CO2 per kilogram of aluminum. Well, multiply that with a couple of 100 tons per yacht, and you know what you're talking about. What I'd also like to share is a bit of the other half of the boat, the steel hull that we usually have. Steel is a different material, and it cannot be as easily made in a green fashion as aluminum is, because the cokes in the steel furnace are actually part of the chemical process of making steel. So just changing the source of energy will not make steel. So production is being developed currently, and it will be there in 5 or maybe 10 years, but it is still the old-fashioned way. However, there is a good recycling industry for steel, and even more interesting for the yacht sector is that we can actually go into reuse. And a perfect example for that is the motor yacht Istros, which was delivered recently with a 67-year-old hull. So all the impact that was made into mining, smelting, producing, welding, etc. of that hull is still being contained in that hull and hasn't been redone to make this new motor yacht. So that is a fine example.
Yes, it is indeed, Bram. Thank you for making that so clear. That we now know that aluminum has quite a big impact. So Lisette, you have studied the different impacts and materials in more detail. How do you identify which materials and which impacts are most significant?
Well, thank you, Katja, but I think the answer has already been given a few times in between today. But the answer is to look at it from a life cycle perspective and then do a life cycle assessment. Meaning that we look at all 4 life stages of a product. So first you have the raw material mining that we take into account. Then, of course, you also have the production of a product. Then we go to the use phase of a product. And finally, we have the end of life, which we hope, of course, to either recycle the product or reuse it. With that model that we have, and we have, of course, our in-house knowledge of the materials that we use, and together with a database of global information about environmental impacts from materials and processes, we can actually make a calculation of it's more like a global estimate of the total environmental impact that comes from yacht production.
Well, that's interesting, that you are, then you have the estimates, but the next stage is, well, you talk to Amanda and you get the real values, but what is more involved with that?
Well, as we all know, a yacht is extremely complex and a lot of materials go on board and are used in the production. So we really need these estimates to know where to investigate, to know at which supply chains we should look for more information, and of course where we can get the biggest improvement with regards to lowering our environmental impact.
So that is pointing us in the right direction, so to say. And so which materials deserve the highest priority from your point of view?
Well, I think the best way to answer that is to split the materials into 2 groups that are of interest. The first group are materials such as steel and aluminum, of which we use a lot, and they have a significant impact. So in total, their contribution to the environmental impact is quite large. But on the other hand, we have materials of which we use not so much exactly, but per kilogram, their environmental impact is quite significant, or actually quite large. Here you can think of materials such as copper, nickel, bronze, but also glues, for example. And these materials, though only using a little bit, they really contribute to the environmental impact of yacht production.
Okay. And talking more about the glues and plastics, do you see other ways to produce them, more sustainable? Or what's your view on that?
Yes, definitely. We see a lot of new ways to look at how these materials are being made, to make them from recycling. But actually today I also heard Ilko talking about using carbon capture to create new material. And I think you also know more about this than I do.
Yes. Yeah, well, that's true, I guess. Yeah. No, but Ilko was referring to that. So when you produce methanol is a chemical raw product that can be used to produce paints and glues and other things like plastics. So that is actually also very relevant for our super yachts. Not perhaps in very vast quantities, but well, I think it is, isn't it?
Yeah, I think so. Guido, sorry to interrupt your discussion here, but so it also sounds to me that the devil is here also quite in the detail.
Yes.
Not so much only in the bigger picture.
Yeah, I think you're absolutely right about that. And talking about details, Charlotte, so you are always more into the interior design, right? And I happen to know that there's a lot of very luxury materials being used in the finishing of these interiors. So my question actually is, do you think it is possible to have an entire interior merely made out of sustainable materials?
Yes, I think there are quite some opportunities ahead of us. So as here, traceability and transparency have already been mentioned. Amanda mentioned it, and also others in this panel. I do have another interesting example for this when we talk about material selection, for example. Because I believe that when clients and their interior designers actually actively seek to incorporate sustainable principles into their designs, they, and together with them, we can actually have a direct and quite a considerable impact while still aiming for the extravagance and the exclusivity that we are looking for.
Yeah. But what do you now know about the actual consequence of the materials you source? Because there are so many. It's quite elaborate, isn't it?
Exactly. It's quite an elaborate topic. And to be honest, to my opinion, we are still at the outset of actually discovering the full spectrum of challenges and opportunities. As coming back to transparency and traceability, as that is a key feature, we see that together with our supply chain partners, some of them are already better organized than others. And where I believe that when it comes to wood-based material, for example, we are already in quite a good shape. Going for well-managed forest sources, there is still a lot to be learned and to be achieved when talking about other product groups. Product groups such as glues and paints, and maybe for us also the group of wood, veneer, as it actually really comes close to the visible part for clients and the designers. But fortunately, I can say that within the Feadship group, we can rely on quite a strong network of widespread expertise. And I see that together we have the intention, but also the motivation to actually push here sustainability boundaries for interior luxury manufacturing.
Yeah, wonderful. Thank you so much, Charlotte. You said something about veneer and finishing, but you didn't really mention another decking material, which is particularly prominent topic, I think, in the sustainability discussion. Could you tell us a little bit more about that, why that is, and if there are some alternatives?
Exactly. A noteworthy topic, because the wood we are talking about here is teak wood. And teak, which is commonly used for exterior decking material, is really a beautiful material. Beautiful when it comes to look and feel, but also the smell. When you walk through our carpentry shop, it's really amazing and exclusive. But the availability of the highest quality teak that we need is very limited. And we already see that it is becoming increasingly difficult to source transparent and well-managed teak, and where we do our utmost together with our supply chain partners to trace back the well-managed origin. We also have this innovation project ongoing, where we identify alternative materials. Materials that have a similar or even the same look and feel, and are as durable when having it on board installed, but which is simply much easier to purchase, to find, with a traceable background, and maybe even becoming recyclable.
Yes, I know.
But actually, yes, I know that you know more about it. It's actually a good idea to pass the word back to you.
Yeah, it's a very interesting one. We have a project at Feadship where we look into 15 alternative decking materials.
Wow.
And it's actually where our science is meeting our craftsmanship pur sang. Let me introduce you to Martijn. He is a senior researcher at Feadship. And Ivo, he is, amongst other things, responsible for the decking material at one of our yards in Aalsmeer.
Hey Martijn, can you get a good reading on the samples?
Yeah, if I use the template for the position, I can get a good stable reading. But there are a lot of color differences, so the position where you take your color measurement is really important. But with the template, it works. We have a dozen or more to go, and then we will know how fast the color changes over time.
All right. And what do you think? Will the polymer alternatives change color slower or faster than the natural wood?
Yeah, some have been designed to be very color stable, but other polymers we only use in the interior because of the UV sensitivity. So with the colorimeter, we will know how fast they change color.
All right. I'm also quite interested in the temperature readings you're doing, because most polymers tend to feel much warmer in the sun than natural wood.
Yeah, so we have a thermocouple in all the samples, so we will know exactly the difference in temperature when they're in the sun. What's also really important is the effusivity. So even if they're exactly the same temperature, a higher effusivity means that the warmth is going faster into your hand or your feet. And most polymers have a higher effusivity than wood, which is why it feels very nice.
Yeah.
And for instance, cork has a lower effusivity, so this transfers even less heat to your hand.
All right.
So by measuring both temperature and effusivity, we will know exactly how nice it feels.
All right. And you're taking pictures at regular intervals also, huh?
Yeah, we're taking pictures, and as you can see, we also need to do some cleaning so that weathering doesn't affect the quality. It needs to look the same as it does on one of our yachts.
All right. So scrubbing decks is now also part of your job.
Yeah, I'm afraid so. Yeah, we also have some smaller samples where we can intentionally make stains, but we have to see how easy they are to remove, unfortunately. We've done some tests with sun lotion, but I'm not quite sure if that's the worst stain you can get in a decking material.
All right. Well, maybe our audience can help, because we have a very experienced audience. So please tell us in the chat or on social media, what is the worst stain you have experienced on any decking material? Thank you.
Yes, it's very interesting to hear that Feadship is really working on these alternative materials. But what about our yard and other facilities? Lisette, you know more about this. Can you tell something about that?
Yes, and I think personally that it's great to see that Feadship, especially in this regard, but actually all over, is leading by example. Currently, 3 of our 4 yards are partially powered by solar panels, really lowering our energy demand. And on top of that, our Amsterdam yard, it is for 100% powered by residual heat from nearby industry. So really making an effort. And with that, we are also trying to go to net zero and actually trying to get there by the end of this decade.
Wow, that is fantastic. So I'm so happy to hear that Feadship is really working on reducing their own footprint. And I know that Bram happens to have some beautiful visuals to explain that even more.
Yes, this is making it a bit more graphical. So here you see the amount of energy that we save by the solar panels on our roofs of our sheds. From the top to bottom, Aalsmeer and Makkum, 10 to 15%. And what you can see is that the Amsterdam yard has almost 30% by pure solar power. And this is partly caused because the systems in the yard are already very efficient. So each bit of renewable energy counts twice. I also like to point you to the windmills in the back of the Royal Van Lent yard. These are sadly not ours, but they connect us to the next bit, because all those renewable energy sources going into the grid, like we saw with the fueling, they also can go into our building process. So we transform the energy into carbon capture and use materials, and we build our boat. And together with the operational side of that, this shows the total effect of the energy transition that we are in right now, and the sector coupling of the energy sector, the chemical industry, and of course the yacht building industry. I'd like to recapitulate a bit and first show you that, of course, we haven't been sitting still in the past 20 years. We have done all kinds of things, partly via regulation, but also we started out with making hybrids. We fitted out our boats with diesel particulate filters, and we are starting to electrify more and more in our propulsion. We will do more in the future, so that is what we talked about today, and even more after that. So ask me again in 5 years. And I owe you one little thing, and that is what we've seen today. What does it mean? So if we define our current impact as 100%, and we subtract our renewable fuels, our zero emission modes, our green aluminum, our CCU materials, what do we see? So this is in about 5 years' times with very near ready technology. So we can save 80%. And I think that is quite in advance of the world trend. So let's lead it this way.
Yes, Bram, that is very impressive indeed. Thank you so much for giving such a clear overview. And yes, very exciting. We are going to invite you into the conversation. So I already see a lot of wonderful questions popping up, but before I dive into those, I have a question for you, because for anyone who was paying attention to our last video, Ivo had a question. What is the worst stain you could possibly get on your decking material? Well, I'm very curious if we will have some answers, insights coming up into my chat. So I will check that later. In the meantime, I have a question for Amanda. How practical is it to recycle yacht aluminium with all the layers of paint and fillers attached?
Well, of course, that's a new process. Well, it's not a new process, but it's a process that is looked at. It is, of course, we need to separate it. And at Yachts, we split everything. We split every alloy so we can recycle it even better. It's not that practical, but there's ways.
There is ways. Well, I think that is the most important thing to know. To Bram, is there any innovation in replacing structural aluminium parts with composites, and how would that influence the impact?
Yes, that's an interesting question. Composites have a lot of good qualities. They're usually light and stiff. However, current composites contain a lot of resins which are based on fossil sources. And the major drawback with composites is that they are very, very hard to recycle. Like Amanda already said, for aluminum, you have to split it into components to recycle it. So that makes composite a bit hard. However, there are quite interesting developments in composites based on flax and bio-based resins. So yes, I definitely see a future.
Thank you so much, Bram. I have one more question for you, Guido. Okay. Does Feadships see any benefits in integrating thin film solar cells in order to provide energy for the hotel loads?
Oh, yeah, yes, we do, yeah. Yeah, there's actually we're working on that development, and for sure you can add quite a bit of energy to your load by having these cells. The thin film cells can actually be bent, so it can be curved on these beautiful curves that our yachts have. So that's really important. And actually, we are looking at combining both the voltaic side with a thermal side. But I'm not going to explain further about that.
You can just keep talking,
yeah.
Right? About everything technical. Oh, well, wonderful. Unfortunately, we do not have time for any more questions. But as I already mentioned before, we will see to it that all of your questions will get answered through social media. And, I have an answer from Jan Vrolijk, who says, worst stain antique we've ever been asked to solve was pizza. Unfortunately, we never got any details about the topping.
Oh.
Well, Jan Vrolijk, that makes me vrolijk. So I think with that, we're going to leave it. I also heard actually that sunscreen is a bad one.
Sunscreen with pizza,
you know something about that?
No.
No, you never heard that?
No.
Oh. Anyway, Guido, I think maybe a little quick recap before we round up this second episode already.
Yeah.
Guido.
Yeah, well, recapping, I think that's not my part of this pie, because I would take ages to recap something. But my main takeaways, I think, again, with the materials and the manufacturer, well, there are quite obvious things you can do. So do it. And why not buying aluminum, which is better in terms of footprint? Let's do it.
Yes. Well, I totally agree with you. Thank you so much, Guido, for this recap. And thank you so much for joining me here today. And of course, thank all of you for joining me. And thank you, such a great engagement from the audience. And we are really looking forward to seeing you again next time, sometime in the fall for our 3rd episode of UNIQ. So looking forward to seeing you then. Thank you so much for watching. See you next time.